Hello guys. So today I want to explain more about how to design your own shapes of the Pathfinders. So the shapes that I mentioned is just three of these, okay? Left side, right side, and the hump. Uh, Other shapes I don't think is would be easy for you to design by your own and make it compatible to the Pathfinder. But as of now, I think left, right, and hum is the most impactful shapes that you can try it out by yourself. So today I think I want to discuss with you about around five topics, cat the overall concept of how to design them, and explain a bit more about the template and the tools that we provide, and maybe get into more detail about how to design the shapes and some method uh, cover that topic. And by the way, this is not going to be like a full tutorial of how to use CAD software because that will take a while. Okay, so let's begin today. As you can see, we already shared the Google Drive here, and we have two folders ready to print. One is the folder containing all the STL file that you can just put it on the slicer of your 3D printer software and then just print it out. Okay, so today just discuss about these two files. Okay, in design your own folder, we provided two files. One of them is Pathfinder Core STL. This one is the mesh file about of the Pathfinder Core, and then the Pathfinder open source 3D model. This one contains all the template, all the tools you need to design your own. Okay, so let's open the CAD software first. In at OptoWorks, we always use Fusion 360 because I think it's a lot of features, and I think in personal use case you can get it for free. So I think feel free to check it out. I think it would be easier to follow by using the same software anyway. Okay, so after you download the software and the file, just open the software. Okay, so this is the final one that I will mention next. So first of all, let's upload the step file that I mentioned. Let's say if you have the file here. Okay, so while we are waiting for the step file to be uploaded into the crowd system of the Fusion, I want to explain more about the concept of how to create the shape of the Pathfinder and what we mean by saying that it's gonna be easy like stacking a sandwich. Okay, so as you can see, the end product is these kind of shapes, right? Left, right, and hump. What we want you to focus is to design the surface, the outer surface. That's it. The rest we already provide every tools and components for you to just plug and play, just like that, and then you finish. So what I mean by plug and play, so let's say after you create the outer surface of the shapes that you want to make, I'll show this. Okay, so after you make the outer shapes, these are the tools that we provide in the step file, which including the plug, the modular plug system. This one we simplify it to match the needs of using just 3D printing, right? Because normally in the injection, the final design will be really messy. All the dimension, all the face will not be like perpendicular anymore. Like sometimes we do have a lot of draft angle, and I don't think it's needed for 3D printers. Okay, so we provide a simplified version of the plug, and then we already include the things we call side cutters. So this will contain your design shapes to be within the same package as other shapes of the Pathfinders. Yeah, okay. Oh, and it's applying this same concept to the hump too. Let me show you. Okay, so for the humps, you just create the outer surface, okay, and then you thicken the surface, and then you cut it. This, yeah, you thicken the surface, you cut it by our template to make sure that your design part is not like overlaps to other area over Pathfinders. And then we will include the rail, like this, like this, like this, like this, and then cut the rail and then make a final part. That's it. That's the whole concept of to make the Pathfinder shapes. So I hope this is really easy to follow. Okay, so I think it's easy enough for you to understand, like it would be easy and just focus on the outer surface. Okay, I guess our 3D file is available. Okay, let's open it up. Okay, so when you open the file in the Fusion 360, or the component will be on high, okay, you can just click and shift and click and just press V, or you can just click one by one on the eye icon here. So as you can see, I also included some of the shapes that we are experimenting right now. But you see, we don't have the mouse here, right? So first step is include the STL file, the Pathfinder core STL that I mentioned before. So insert mesh, choose and Pathfinder core STL. Click OK. Here you can have the mesh file that represent the Pathfinder core, so you can have more referencing point when you design the shapes. Okay, so before we go further, after this I'm going to show you like step by step how to design the shapes. I want to discuss just a little bit more about the common method to design the surface. Okay, open the PowerPoint again. Okay, so I want to discuss about these two names: surface modeling and freeform modelings. Each of them have its own benefits and drawbacks. Okay, and I think in some shapes, like a normal average shapes, I think it's better to make it by the surface modeling method. For some shapes like a X large, wave, or thumb large, I think it's better to make it by the freeform modeling. I think both of them have its own pros and cons. So surface modeling, to make the surface this way, we normally use the common feature base. We sketch things and add some feature. So in this case, as you can see, we have like a tree sketch on the plane, like at the back of the shapes, at the middle, maybe on the apex points of the shapes, and at the front of the shapes. And then I create the sketch governing the surface. Okay, this way I have full control of the radius of the curve. Like I can control how concave or how convex it is, and how wide it is from the center of the mouse. Like in this way, surface modeling, we have a really full control and the precision of the surface. Vice versa, for freeform modeling, as you can see, these kind of shapes will be difficult if we apply the same methods from surface modeling. I think it's doable, but I think it's not commonly used for these kind of shapes. Like when you have like an organic flowing surface, I think it's better to use like a freeform modeling. So this way it would be like creating a canvas, and then you can just pull like increase some crease, pull this one out, push this one backward, and boom, you finish with the shapes. So in the V1 Explore box, X shapes, wave, slash were made by using freeform modelings, and the rest I optimizing all the angle and the curve using the surface modeling method. So let's try it out. Okay, so let's say you just have this. Okay, I will show you. Let me check something real quick. Okay, let's make some surface modeling part for the side part first. Okay, so in Fusion, when you create new part, when you want to create new parts, we supposed to click on these new components. Okay, and you name it let's say surface example 1. Okay, so as you can see, we are entering the activate the components here. You can click back on this one. Yeah, okay, surface modeling. Okay, so let's get started. So in my case, what I normally do is to create 3 planes. One of them is at the back, 30. Okay, I think it's enough. Another is maybe 5. Okay, another one is 40 at the front. So you can name it black back plane, mid plane, mid front plane. Okay, so let's design something simple. Okay, so when you start, you already construct the plane. Then you click sketch. You click the plane that you want to create the sketch, which is, in my case, the back plane. Okay, so just create some curve on it. I just randomly do it. Okay, you can learn more about the shortcut. I normally use shortcut, and then just, okay, you can click on these and then like add some dimensions. Sorry. Okay, just to show you like you can get the really like a specific detail on this one. Okay, then you just maybe 24 meters like this. Again, on the mid plane, let's say you want it like this time. Okay, just like that. And then lastly, front plane. So normally at the left side, I don't really add any detail much on the front because there's no contact point with the thumb at all normally. So just create some, you can even create the line. Okay, doesn't have to be the arch. I normally want to control it by the radius of it. play around with this. This way and 28. Okay, I guess it should work. Okay, so surface modeling. You just create a sketch of the profile. This is the easiest way. You can use extrude, sweep, revolve, anything else. But in our case, I think it's better to use loft. So loft is just connect the profile one by one, like this. Okay, you can have the rail as well, but in our case, we can just click this way and just move around. Sorry. 30, 35. Okay. Boom. I guess we finish. Okay. So we have like a curve that have the apex, the concave point around here, and flare out to the top. Okay. Next step. Let's say I want to make this shape. I will optimize, by your own. Okay. Click solid. So the concept is the first tool. If you use Fusion, we have the features called boundary fill. So you click this one, you click the surface that you just design, and then you click the side cutter that we provide. Okay. So Fusion will find the enclosing volume from these tools, and then as you can see, you can click this and you click OK. So you hide the side cutter. So now you just have the side shapes that able to I would say match or interface with the Pathfinder core. Okay, what we need next is the plug system. So unhide the left plug. Okay, in Fusion we use this one. Combine. I believe all the cast software have this kind of a Boolean operation to add, to cut things. Okay, you click the part, you click the plug, and in Fusion just keep to make a check. Okay, otherwise when you combine it, these components will be gone. Just leave it like this. Okay, so as you can see, you finish making your own shapes. Ta-da! So you might think, oh, the edge is gonna be hurt when you grip it because this is like a really sharp edge. So normally just fillet it out. So fillet is like a really big topic. I'm not gonna explain a lot. Just try it out. Okay, this is like constant. If you want to control every point of the radius along the edge, just click variable, and you can specify one by one, like how much do you need on this point, how much do you need on that point. Okay, just like that. Okay, for the demonstration purpose, just make it simple, just 1 millimeters, then you finish. So, and by the way, you cannot just mirror to the right side because the plug is not the same. So you're supposed to mirror the parts during when you just finish creating the surface. Okay, so you click create, click mirror, click the outer surface, click the mid plane, and then you finish on the right as well. So I just do it real quick. So side cutter, boundary fill, click the right surface, click the side cutter, click the enclosing volume, then all of these, combine this one with the right plug, tick. Okay, finish, and then fill it out. Okay, so after this, it seems like you can play around with each of the parameters or the dimension by yourself. Okay, let's say if you want to print it, just right click on the body, save as match, and click OK. That's it, you finish. Okay, now you finish the side shapes. Let's move on to the hump. Okay, So the hump cutter. So let's say we want to make it like a maybe, I don't know, pointy. So to make the hump, normally I will create three, like that will be three sketch in needed to make the like complex enough surface for our humps. Okay, so I will show you. First, create sketch. For the hump, I think you don't need to construct new plane. So just use the XC, yeah. Here, yeah, yeah. So what I mean by you able to control, you get a full control of the surface is like this. Let's say you want the apex point of the curve of the hump on, like, let's say 39 millimeters height. You can do that by using this way. Then in my case, I just use the fit spline here. Oops. Yeah, you can click delete after. Click delete. For the spline infusion, after you click it, they will show you the handles. So click the mid, the I don't know, the central one. Click it to the construction line. Make it perpendicular. Otherwise, you will have like some seam on the midpoint. And then you can specify how large it is. Let's say 30 millimeters. Yeah, you can use any. You don't have to use the fit spline as well. You can just use like arcs and line, fillet it out. Yeah, do it by yourself. Mirror to the other side. Finish. Yeah, so this is the first sketch. Okay, the second one is on the ground. I think this way, I think it's the easiest way for you to follow along. But the concept is really simple, right? You just make some enclosing surface like that larger than our hump cutter, and then cut it out by our hump cutter, and you finish. Okay, let's get back. So here, let's say you have a really long hand, so you want the hump to be really further extended, further backward. It's fine. Okay, this one is just a little bit tricky. You need to make sure that the edge of the hump, the bottom profile, cross these two lines. Okay, I make it really pointy. Okay, click the handle. Make sure that this handle is perpendicular to the center one. Mirror to the right side. Okay, click finish sketch. So you have two sketch already, and then you create the spine. Click on the YC plane. Okay, before you do anything else, you just have to project, which is the shortcut is P. Click the point here. You see why. So you need something to have the same starting and ending point here. Yeah, this is what I call spine. So this one have to be connected to the mid section of the mouth, and also the hump, the bottom section of the mouth, the hump. That's it. Okay, let's say we make it this way. Click sketch, finish, and as I said, like, I think it's the easiest way is to use laugh. You can use anything else if you know how to use it. Just feel free. I guess it's the easiest way. Laugh. Okay, this is the first profile. This is the end profile, and then we add the rail. Click OK. Next step is to thicken, to make it into the solid part. Thicken. Normally, I think this one is based on your 3D printer as well, but in our case, 0.8, 0.9, 1 millimeter is fine. It's strong enough to hold your grip. Okay, make it outer. Okay, and then what I said, it's really simple. As you can see, these are the excess part, right? Just combine this one with the hump cutters, but instead of adding it together, joining it together, we cut it instead here. Okay, and then we just hide this part. Okay, we almost finished. Okay, so we will need to add the rail. So before you do that, you have to do this. Click surface, click offset. You know why. Click here, click OK. Because right now, I will show you. If you combine the hump with the rail, click join again. Okay, keep tools. What you get is the rail, the hump, and this excess part. You need to cut it off, and to cut it off, we need this outer surface. That's why I offset it already. Okay, right now you just hide the rail plug and click split body. Click the body. No, click the body and click the surface. Click OK, and as you can see, we have split our hump, and this is almost finished. Lastly, as you can see, this is have a sharp edge again. So just click F, or you can click here, fillets. Click here, 1. Normally it's like doesn't work. So any number less than 1, because the thickness is 1, right? And some part, it's really difficult for the CAD software to make the radius of the fillets as you specify. So something smaller, and that's it. So right now you just finish the side chips and the hump design. Okay, so you just finished the surface modeling method. Let's try the freeform one. So you can even begin by the existing one. Okay, just hide the part. Okay, you get the sketch already. I'll show you again how to make the freeform. Okay, activate your design component. You can create a new one, but you can use this one because you're going to use the same sketch that we already did. So click here, create form. Okay, so we all still have like a basics to like the feature of normal CAD here. Law of you can use law of click. It's like the same, right, as you can see. But right now you have 2 more parameters to play around. So the 2-handle T-spline surface, I think it's better to start with the low number of the faces. Okay, because you can add it later, but if you want to remove it later, it will be difficult. So start by small first. Okay, you will know what I mean after you try it out. So let's say we want these kind of maybe more. I show you. Okay, then connected, not connected. Yeah, it depends on what you want. Okay, let's start by this. Okay, so what I mean by you don't have a full control like the surface modeling method, because in surface modeling you can just turn on this, back this. Okay, in surface modeling you just adjust the dimension of each cross-sectional profile. Okay, and then the surface that you make will change according to that. But for freeform modeling, this T-spline, after you create the initial like T-spline curve, you cannot go back to edit each section anymore. Okay, and right now what you have to do is just this, like click on the edge or the face, move it around, like drag it like this. So I think it's better to just turn on the side cutters, so you still see that this is still contained within the side cutters. Here, let's say I want to make like a thumb rest or something here. Maybe pull this down. You see? So right now, like you're still able to control to rotate these, but you cannot specify by some dimension referencing to some ground plane or some part. Yeah, so it's like an organic way. Let's say we finish, you click form, and you finish the outer surface, and then you repeat the same process again. Boundary fill, click. All right, and then you hide this, you hide this part, left part, combine here, hide it, you finish. You see? Then you just fill it with some number, I don't know, play around with it. Okay, one. This one is two. Like this, so just play around more. Bam. Okay, and then if you want to edit the shape again, you just click here from, double click it, then you click modify, then drag around. Okay, I will show you example of the Hump as well. So turn off, create this one, then create form again this way. This time actually, like, you can create the plane like this. Okay, and then you increase the face and you move around, you sculpt it to fit your design shapes. But I think it's still easier to start by some sketch and then add some normal features like loft. Okay, loft to here, have the spline, minimize the number of faces at the beginning. Okay, this, maybe like this, maybe like this, and click OK. And for some shapes like this, that if you want to make a symmetrical mouse, you can click the symmetry, click here and click the face that's supposed to be symmetrical, click OK. So in this way, once you move, the other side will move in a mirror way, so it will be, yeah, just like that. So you just move around, but in this way, as I said, you don't have like a controllable surface that you can, like, you cannot specify like this is 10mm height or something. It will need, yeah, it's not suitable for that kind of precision, like yeah, surface. Okay, but you get what I mean by you cannot create these kind of shapes by normal surface modeling as well. Maybe if you can, it would be difficult. So yeah, because let's say if this shape is okay and you want to optimize it further, you just have to just move around and count, like, okay, I move in like -4mm on this point, and then like try it out. So yeah, and then the rest is the same process as you did on the surface modeling method. It's just like the thicken outside, Hump cutter, just, yeah, combine it with the Hump cutter, cut it, that, yeah, you know what I mean. Okay, so I guess you have a rough idea of how to use the freeform modelings. I think the key is you can find some tutorial online about how to manipulate T-spline in a good manner ways. Okay, so let's say you want to modify existing shapes of the Pathfinder. Let's say wave. Okay, as you see, I already included the surface, the outer surface of the wave already, but you cannot do anything about it because this is just the first surface file. What you can do on this one is just to make the like boundary fill, click cell, click, and then did I did something wrong? Yeah. Okay. Oh, okay. Sorry, I need to activate on this one. I forgot. Sorry. Boundary fill, click, click, click. Then hide it. Okay. As you can see, you cannot adjust anything because this is like a final already. So what I want to show you is, let's say you want to move like the ring finger further backward. Okay, you can do it by the freeform modeling, and by doing this way you have to click create form, and then because we already provide you the outer surface, right, you can click convert. Click here, you click the B-rep face to T-spline. Click here. So the fusion will try to recreate the same curve using the T-spline surface, and you just have to increase a lot of faces for the program to able to match the existing surface. Yeah, like that, because I cannot provide this kind of file in the step file. This is like a fusion file. So just like that, and then let's say you want to move the ring finger backward. Maybe you can click this, modify, soft manipulation, so move everything across as well. No, it's too big. Okay, maybe like this. Drag, click here. Okay, okay. So compared to original sketch, the surface, you see that right now we have more room, more gap on the ring fingers. Yeah. So I think I cover the basic part of how to create your own shapes with our provided tools, including the side cutter. Sorry, activate here first. Side cutter, the plug, the hump cutter, the rear plugs. Okay, so other than this, I will just mention about the tips and tricks. Okay, so let's say if you want to make some hump that is really further backward, extended to the back. Okay, in this way, I think it's possible that the hump will scratch your mouse pad because like there's no skate underneath at the edge. So I have included in the hump skirt for you to have some reference. If you want to make some like a really extended hump, you just add this one, and I think if you can use CAD software, I think it's not going to be that difficult just to add some feet of the hump to have these kind of features like this one. Okay, so I provide a elongated edge or R. Actually the name is extended edge and R, sorry, and like this. So in the large and long part like this, I think we supposed to add this as well. So this is one tips. Okay, and overall I just want to mention just a little bit about the shape designing process and the thought behind why we make different shapes. Okay, so based on our study with various hand scan with top ranked players, and yeah, what we learned is the thing that affect your gameplay is there's two parameters. One of them is stability, the other one is maneuverability. So having less contact area of the mouse, let's say you have a mouse with really flat side shapes and a hump, like provide like a full like minimum touch point to your fingers. That way it allow you to wiggle around with the mouse with your finger. This means you have less stability but you have full maneuverability. So overall the shapes that we design in the V1 box, we provide these shapes because it's allowing you to like swipe around these two parameters, like wave shapes like provide a lot of contact, a lot of support to your fingers. That is also make it really stable but reduce the maneuverability of your finger with the mouse. Okay, like in some games like tracking games or tactical shooting games, it's require different pros and cons of the shapes of the mouse. So yeah, this is just some like basic concept, basic idea about why we make a lot of shapes and why you need to fine tune it, because like it have to be match the requirement or the scenario that you face in the game. Okay, so lastly, I want to mention that I hope you have fun designing new shape of the Pathfinder, and please join the Discord to have a to discuss if you have any problem, and you can share the file. We are really more than welcome to upload that into our database and test it out. Okay, so I guess for today that's it. Have fun. Bye bye.